There we go. Okay. So homework quiz did not go so hot. Let's go ahead and take a look at the homework quiz problem. Problem 1. Most of you did okay with the nomenclature and the identifying geometries. A few people made some mistakes, but that's really definitional. But the first homework problem is very much conceptual and mathematical, so I wanted to go over it. So can you remind me what the problem is? You did fine on it though.
Yeah, number 9.
Yes.
Silver ion reacts with cyanide ion to form a colorless complex ion, AgCN2, which has a Kf of 3 times 10 to the 20. Calculate the concentration of Ag plus in a solution prepared by mixing equal volumes of 2 times 10 to the negative 3 molarity AgNO3 and 0.2 molarity NaCN.
So there's a couple things that are important here as we read through the problem. It tells us the reaction. The fact that it gives us a Kf lets us know that we're doing a formation reaction. I should balance my formation reaction. You notice in the formation, it gives you the formula for the metal complex being formed. It's actually quite difficult to predict the metal complex that's going to be formed. So a lot of times I'll have to tell you what metal complex is being formed. We have some things that can give us hunches in terms of what's going to be formed. The silver and gold and copper plus ones are always going to pick up 2 ligands. They don't go octahedral, they don't go tetrahedral, they don't go square planar. They always pick up 2 ligands, they're always linear. But when we start looking at nickel, nickel could be square planar or it could be octahedral. Depends on the ligands. So in this case, we're told what the metal complex being formed is. We would name it dicyanoarginate. Right, because we've got 2 cyanides, we've got silver, it's a negative ligand, or sorry, it's a negative metal complex, dicyanoarginate. And what we notice here is we're given amounts, right? We're given molarities, and it says equal volume, so we could pick any volume we wanted, right? And we're just going to make the volumes the same. What's the best volume to pick? One anything, right? 1 liter is going to be the easiest thing to pick. Right, we pick 1 liter of each thing because it's got to be equal volumes. We could pick 50 liters, we could pick 50 milliliters, we could pick 1 trillion liters. It just has to be the same. And when we get to pick, we almost always want to pick something that's going to be number 1 because that makes the calculation easy. Now, when we look at this, there's another thing that's really important. The Kf is a really large number. Whenever we have an equilibrium constant that's large, what's that mean we should do? Yeah, it's going to be very product favored, and this is going to be essentially 100% product favored. So this is going to tell us that we need to do stoichiometry. A lot of you jumped straight to doing an equilibrium table. But if you do an equilibrium table with an equilibrium constant like this, you can't use x is small. You have to solve the quadratic, and you have to keep about 12 sig figs in order to get the answer correct. That's the whole reason and this is the same thing we saw back in week 2 when we were doing our precipitation reactions. We saw these really large equilibrium constants, and we said, rather than doing it as 1 equilibrium, we're going to do a reaction, then we're going to do an equilibrium to correct it. So let's go ahead and do our stoichiometry. Come on in. We're doing a lot of 129 questions right now. Okay. So we're going to go ahead and do our stoichiometry first. We're going to have Ag plus 2Cn minus goes to Ag Cn 2 minus. We're going to have, if we've got 1 liter, we've got 0.002 moles. We've got 0.2 moles. We've got 0. This is going to be stoichiometry. Obviously, limiting reactant is?
Me?
Yeah.
Oh, no. I don't pay attention.
But you can still do stoichiometry. Oh man, okay.
It's too early.
So,
It's gonna wait till 6 o'clock. I got you.
okay, so we can tell just by the fact that the silver, there's a lot less silver than there is cyanide. Even though we need twice as much cyanide, we've got about 100 times more cyanide than silver. So the silver is going to be our limiting reactant. We're going to go ahead and subtract that. Get our 2-to-1 ratio in there and produce our products. Of course, if it's our limiting reactant, it goes to 0. This is going to go to 0.196. Thank you. And this is going to go to 0.002. And we look at this and we say, great, there's 0 silver left. And this is where we get away from 124. And we say, actually, what we learned in our next chemistry class is that we can never have 0. We have to establish an equilibrium. So we're going to go ahead and establish our equilibrium now. And again, we're going to do a trick, right? So when we look at this equilibrium, the equilibrium is going to be going back the other direction. It's going to be what we used to call our redissolve, right? We wouldn't use the term redissolve because we didn't form a solid. The dicyanoarginate is a metal complex. It's an aqueous thing. So this would be a dissociation, right? In order to look at this dissociation, we're going to look at the reverse reaction, just like we did when we were forming precipitates in week 2. We're going to get Ag+, we're going to get Cn-, we're going to ice it, and all that really matters is the initial, and we're going to use the extra small approximation. The concentration of the AgCN is going to be 0.002 divided by 2 liters, because that's going to be our total volume once these things are mixed together. So it's going to be 0.001 molarity. Our Ag+ is going to be 0. Our Cn- is going to be 1.96 divided by the 2 liters, 0.098 molarity. And the other thing we have to recognize, this was the other place where a lot of students had trouble. They went to the ICE table and they still used the Kf. But notice this reaction is not a formation reaction anymore. It's a dissociation of a metal complex reaction. So our K reaction is going to be 1 over Kf. This is part of what allows us to use the X is small approximation, because when we calculate this K reaction, we're going to get 3.33 times 10 to the minus 21. We're going to get a very, very small number. That small number says, look, we're really going to stay as our reactant. We're not going to make much products. We're going to have minus X plus X plus X. But this X is going to be a really, really small value on the order of minus 21, which compared to 9 times 10 to the minus 2 or 1 times 10 to the minus 3, X is going to be very small. I didn't give myself enough space, so let's go ahead and do this up here. We're going to have, no, let's keep going. We're going to have 3.33 times 10 to the minus 21 is equal to products over reactants 0.098 X divided by 0.001. The other mistake that was really common, got to square the 0.098 because we have, oops, a balanced chemical reaction with that 2 out front. So that means we're going to square our concentration of cyanide. When we solve for X, I can't remember the answer, but you get a really small value. In terms of what I was talking about before I started the video, this is, again, one of those modes of thinking where this is like a parallel thought process, right? This is identical in terms of process to what we did with forming a solid and then having the solid redissolve. It's identical. Reaction with a big equilibrium constant, equilibrium to figure out how much redissolves. It's identical. But for some reason, I changed the words and we can't recognize the process anymore. So, parallel thought, really the same thing we've done before. But different concepts, different words. Same physical process is dominating it. Other questions? That was the only thing I wanted to do on the video. We've been kind of having little other conversations. If you want more office hours live, more of you need to show up to office hours. Okay,